Have you at any time imagined what happens when lightning strikes an aircraft? It could be a very scary situation if you are on board an aircraft that is 35,000 feet up there in the skies. It's a question that's likely crossed your mind at some point, especially if you're a frequent flyer or simply someone fascinated by the wonders and mysteries of our natural world. Airplanes, as we know, spend a lot of their time in the sky, soaring through the vast atmosphere, often at altitudes where the conditions are ripe for thunderstorms. Now couple this with the fact that these airborne machines are primarily made of metal, a great conductor of electricity, and you've got yourself a high-flying lightning rod. And yet, despite these seemingly perfect conditions for a potential disaster, air travel remains one of the safest modes of transportation. How so? Well, it turns out that the brilliant minds behind aircraft design had thought of this too. The inevitability of an encounter between an airplane and a lightning bolt has been a significant factor in the design and construction of these metal birds. In fact, airplanes are built with this inevitability in mind. They are designed not only to withstand a lightning strike, but also to channel it, to guide the electricity along a path that minimizes damage and ensures the safety of those on board. Quite ingenious, isn't it? Now you might be thinking, surely this must be a rare occurrence, right? Well, not quite. Surprisingly, each commercial airplane in the US can expect to be struck by lightning at least once a year. Yes, you heard that right, once a year. Globally, lightning strikes aircraft hundreds of times each day. Yet despite these frequent electrifying encounters, incidents of lightning-causing accidents are incredibly rare. It's a testament to the marvel of engineering that these aircraft are and the foresight of those who design them. But what exactly happens when lightning hits an airplane? You might be surprised. To understand what happens when lightning strikes an aircraft, we first need to comprehend the nature of lightning itself. So let's dive into the science of this spectacular natural phenomenon. Lightning is essentially an electric current. But how does this current form? The answer lies in the heart of a thundercloud. As the storm brews, different types of ice particles within the cloud collide, creating an electric charge. Over time, the entire cloud fills up with electrical charges. The positive charges, or protons, form at the top of the cloud, and the negative charges, or electrons, settle at the bottom of the cloud. Now, these charges don't like being apart. They're constantly seeking a path to reunite. And when the attraction between the separated charges becomes too strong, it breaks down the air resistance, creating a path for the charges to reunite. This rush of electrons racing towards the positively charged ground is what we see as a lightning bolt. But don't be fooled by its fleeting beauty. A single bolt of lightning is a powerhouse of energy. It can heat the air through which it travels to temperatures around 5 times hotter than the surface of the sun. That's approximately 50,000 degrees Fahrenheit. To put it in perspective, that's over 13 times hotter than the temperature required to melt steel. And the power of a lightning bolt? It's measured in the millions of volts. On average, a lightning bolt carries about 1 billion volts of electricity. That's enough energy to light up a medium-sized city for a month. So imagine for a moment this colossal energy hurtling towards an airplane cruising at 35,000 feet. It's an encounter of epic proportions, a clash between human-made technology and raw, unbridled natural power. Now that we understand the raw energy and power of lightning, let's explore what happens when it collides with an airplane. Lightning is a powerful, destructive force, but when it strikes an aircraft, the outcome isn't what you'd expect. Now, imagine a stormy night, a bolt of lightning streaking across the sky, and an airplane flying right into its path. It sounds like a disaster in the making, doesn't it? Yet in reality, the passengers inside the airplane would barely notice anything out of the ordinary. How can this be? Enter the Faraday cage effect, a principle named after the English scientist Michael Faraday. This effect explains that an electric charge will only move around the exterior of a conductive material rather than penetrating it. In simple terms, the airplane acts like a metal birdcage that shields its occupants from the electrical discharge. So when lightning strikes an aircraft, the electrical charge doesn't zap everyone inside. Instead, it flows around the exterior of the airplane. This is because the skin of the aircraft, mostly made of aluminum, is a good conductor of electricity. It allows the electrical charge to move freely around the surface, eventually exiting out another point, leaving the interior untouched. That's why during a lightning strike, passengers might see a bright flash and hear a loud noise, but they won't feel any electric shock. The plane's systems are designed to handle this external surge of electricity, ensuring that the flight continues safely and smoothly. But it's not just the material that helps protect the aircraft and its passengers. The design of the plane also plays a key role. Airplanes are built to withstand extreme conditions, including lightning strikes. The structure is robust and all sensitive components are well protected. There's also a series of rigorous tests that new airplane models have to pass, including simulated lightning strikes, to ensure that they can handle such events without catastrophic failures. So while a lightning strike might sound terrifying, the actual effects on an airplane are minimal due to clever engineering. Although the passengers and crew might not even notice a lightning strike, what happens to the aircraft afterwards? In the aftermath of a lightning strike, the aircraft may sustain superficial damage. This can include minor scorching, pitting, or even small burn holes on the aircraft's exterior. These are typically found at the strike's entry and exit points. It's important to note, however, that these are generally cosmetic in nature and do not compromise the structural integrity of the aircraft. The primary concern following a lightning strike is not the cosmetic damage, but the potential impact on the aircraft's electrical systems. A lightning bolt is a powerful surge of electricity, and modern aircraft are heavily reliant on electronic systems for navigation, communication, and control. That's why, after a lightning strike, an aircraft must undergo a thorough inspection. This is not a job for the faint-hearted. It's a meticulous process that involves checking every inch of the aircraft, from the nose to the tail and from the wings to the wheels. The inspection team searches for signs of damage, both visible and hidden. They examine the aircraft's skin for burn marks and holes, and they scrutinize the electrical systems for any signs of disruption. They also check the fuel tanks and lines, as lightning can cause sparks that might ignite fuel vapors. This might sound like a lot of work, and it is, but it's absolutely necessary for the safety of the passengers and crew. The good news is that aircraft are designed to withstand lightning strikes. They are built with lightning protection systems that guide the electrical charge from a lightning bolt safely around the aircraft and out again, minimizing the chance of serious damage. So it's not a question of if an aircraft can survive a lightning strike, but rather how well it can. The answer is, very well indeed. Modern aircraft are incredibly resilient, and the safety standards in the aviation industry are second to none. So, while lightning strikes may leave a mark, they rarely cause significant damage to an aircraft. So should you worry the next time you're flying through a thunderstorm? Not at all. Just relax the next time you are airborne and savor the peace of air travel. Lightning and thunderstorms are little distractions with no effect on the aircraft you are traveling in. There are robust safety measures in place to protect aircraft and passengers from the effects of lightning strikes. These measures are the result of years of research, technological advancements, and stringent regulations. Serious incidents resulting from lightning strikes on aircraft are exceedingly rare.